So it is the 15th of January. We're just continuing on our test here. The optocoupler and the transistor have been removed from the circuit. All we're left with is the resistors, the diode bridge, resistor across, and then parts of the capacitor bridge that were in there. So we're going to just start at the beginning. Over here we have the 120 volt signal. You can see on the scope, 60 Hertz. Looks exactly like it should. So now we're going to check the other side of the resistors, and we're looking for a smaller waveform. I guess I should have read off the scales to you. So we are looking at the scope probes are on a divide by 10. We have 5 volts per division, so we're just over 150 volts peak to peak, and we're at a 10 millisecond sweep time, so we've got a 16.67 millisecond peak to peak, or period on the wave. This is the waveform before I change the scale. I'm just going to change the scale so we can read it. So this is the somewhat distorted waveform. I left the voltage scale at 5 volts per division. I just changed the probes from divide by 10 to divide by 1. So we are now showing 2 squares, which is about 10 volts peak to peak, and it's a modified distorted waveform. We are across R3, which oh no, we're not across that. We're across the 2 big resistors, so R1 and R2. We're across where the capacitor C2 would be if C2 was there right now, just at the beginning of the diode bridge. So we're getting a distorted waveform there. We should have a distorted waveform on the other side of that. That's very odd. Okay, I removed capacitor C1, which is the only other load besides R3 on the circuit right now. So I'm still getting the distorted waveform. I'll unplug it and remove resistor R3. So now with the load completely removed, the sine wave looks a little bit different, but it's still recognizable as a sine wave. I'm going to move the probes with no load on them to the other side of the diodes, and I'm expecting a nice set of pulses. In keeping with Trust Your Instruments, this is what I'm seeing on the other side of the diode bridge. It's not looking exactly like the pulse train that I was expecting it to look like, and maybe that's part of my problem. So I am going to go back and verify that I've got the 4 diodes. Well, all 5 of the diodes are identical though. I'm going to put resistor R3 back in and see if this circuit gives me any pulses that resemble a full bridge. This looks more like a combination of a half bridge and a full bridge. If it was only these, it would be a half bridge, and then the pulses in between, I'm not sure why they're narrower. It's almost like one of the diodes isn't recovering fast enough. Anyway, onward. Okay, with the R3 resistor back in, it looks pretty much like I was expecting it to, like a full wave. Oh, that's very interesting. So that looks like pulses at the 5 volts per division. At 2 volts per division, it kind of goes weird. Oh, I guess it's cutting the top off the wave. Okay. In any case, that is a signal that I was looking for, and I will now see if I can figure out how to check the transistor. Okay, we got 12 volts coming into this 4.7K resistor down to the positive side of the transistor. I can't remember what that's called. Deep drain source. Anyway, the positive side. From that point to the gate, we go with another resistor, which gives it some current, and then from the bottom of the transistor, the output of the transistor, to the diode, and then to neutral. So the diode's working, the LED's working. Sorry, not the diode, the transistor's working. The diode's working. So next we're going to check out the optocoupler. Okay, so the test for the optocoupler, we're putting 12 volts in here through the 4.7K resistor, through the diode on the high side of the optocoupler, through a resistor, in series with this diode. And the diode lights, it's not on very much, but the diode isn't blown, it does pass current. So we're on to the next test for the optocoupler. So I've got a little circuit here where I've got the optocoupler in the middle. I have 12 volts that I connect to this side, goes through the diode on this side to the negative, and then this side is just hooked to the middle, which is presently at about 3.5 volts. Goes through the optocoupler gate, the isolated side, and then turns on the LED. I'm not getting any current through the LED. I've tried a different opto-isolator, that hasn't helped. So I got to go and find out some specs on my optocoupler and see how much current it actually takes to drive it on. So here we go, powering up the high side of the optocoupler and having the low side turn on the LED. So it's working okay. I had the pin out incorrect, which is a really good reason for it not to work. So here we are again at the scope. We are just over 8 milliseconds horizontal, 2, 4, 6, 8, yeah, but well, AC wave would be 8 1/3 milliseconds. And then we vertical, we're at that's interesting. Okay, I'm going to say it's 2, what was it, 5, 6, 7 volts maybe. So a 7 volt peak to peak, half or full wave bridge. We just have the pulses, the positive pulses from the AC, and they're going into this system here. So we're going to take a look at that. Back to this circuit, we're on the output of the diodes. Now we're going to take a look at the capacitor. I'm going to try not to pull the capacitor out of the board. It's putting a lot of force on it. Let's go from the other direction. There we go. On this side we will disengage. Well, actually that's kind of where it has to be. All those. So we're going to then take a look at the scope again. We're just looking at the voltage across the capacitor, which should be firing 120 times a second. It should be turning on that transistor there, which should turn on the optocoupler, which then triggers my LED. It's not triggering the LED, so we're having some trouble here somewhere. We're trying to track it down. So the signal on the scope looks a little goofy. We're seeing we are still at 5 milliseconds, so that's about an 8 millisecond for one side, and then you see a dip, and it goes higher, lower. We've got 3 different levels here, we should only have 2. So the capacitor is charging up one half cycle and discharging on another half cycle, which really isn't what I was expecting it to do. So I'm going to go through and check the circuit again and see if I missed something when I was putting it back together.